So today we will discuss with the code optimization. The main purpose of the code optimization is the target code may be extremely inefficient both in terms of execution and the target code size. The code optimization refers to the technique used by the compilers in order to improve execution efficiency of the generated code. It can be machine dependent or independent, works on the target code. Uh, Optimization parts of the compiler that performs the optimizer is the part of the compiler that performs the code of optimization. The various techniques of the code optimization are elimination of the common sub-expression, dead code elimination, compile time elimination, frequency reduction, strength reduction, and the loop invariant code motion. Now the first is the elimination of common sub-expression, like we have x is equal to a cross b plus c and y is equal to a cross b minus d. Here the a cross b expression is evaluated two times in the x expression as well as in the y expression. So it is better to evaluate a cross b first, like we store a cross b in a temporary variable temp. Now we will write x is equal to temp plus c and y is equal to temp minus d, the same expression where we have a cross b we have evaluated as temp. Now we will use temp plus c or temp minus d. This is the elimination of the common sub-expression. Second is the dead code elimination. The dead code is also called the unreachable code. Like we have C program, in a C program we have function, void function, integer x, integer y, x equals to 1, y is equal to 1, y is equal to 2, print percentage d and y, right? Now here I have mentioned the dead code by comment slash. These are all the dead codes because in the if we because we are using only the y variable, nothing else. So we can ignore the x statements and we can also ignore the y is equal to 1 because the y is equal to 1 is you can say overrated by the y is equal to 2. Here is the expression, that is the dead code. We can write the void function name will remain as such, integer y, we will declare the y type as integer, then y is equal to 2, then printf percentage d and y. Because if we remove these all dead codes, the program is not going to affect anymore. You understand this? This is the dead code elimination. Third method is the compile time evaluation. Like we have x is equal to 10 multiplied by 2 plus 3 multiplied by 2 plus 4. This expression is time consuming. If we evaluate this compile time, we can write x is equal to 30. In this method the constant folding is used. Now next method is the strength reduction. Strength reduction is replacing high cost operator with the low cost operators. Like we have 2 cross y that can be replaced with I plus I. Similarly we have I square that can be replaced again with I plus I, right? Next is the loop optimization. Loop optimization can be done with the help of three methods, that is the elimination of loop invariant code, second is the elimination of induction variables, third is the strength reduction within a loop. So first method is like we have the elimination of loop invariant code, and this is like I is equal to 1, we have c is equal to 10, then d is equal to 20, right? So we have a while I is less than or equals to up to 1 lakh, we are evaluating this expression. A is equal to a plus b, b is equal to a plus c cross d, b is equal to a minus b, and I is equal to I plus 1. So here this all the four statements will executed 1 lakh times. So C cross D, if we evaluate before the proceeding further, then it will reduce my time, like I have done over here. We have written T is equal to C cross D. We have reduced this. A is equal to A cross B is equal to C cross D, B is equal to A minus B, and I is equal to I plus 1. Now here I will write in terms C cross D, in terms of that I will write the T variable. B is equal to A plus T. Then it will reduce my the loop optimization. Thank you.